In this video, we're going to look at the equation of a tangent. In the question here, it says the line L is a tangent to the circle x squared plus y squared equals 45 at the point minus 3 and 6. The line L crosses the x-axis at the point P. Now that line is shown to you on the green line. So what it says to work out the coordinates of P. I'm also going to extend this question by finding the area of the triangle formed. So first of all, we need to work out the equation for the tangent. Now what we do for a question like this, we know that the line L, the tangent line, passes through the point minus 3 and 6. So what we're going to do, we're going to mark a coordinate here, and we're going to call that the point, let's say call it Q. Now this Q is minus 3 and 6. That's the point that meets the circle and it meets the tangent line. Now when it's written in this form, x squared plus y squared equals a number, we always assume, especially at GCSE, that the center is always, the center of the circle is always centered about 0, 0. 0 for x, 0 for y. So what we do is we draw in the radius from the point Q down to the center. Now what we want to do is work out the gradient of that radius. And we're going to do that by saying MR for the gradient of the radius is y2 minus y1 over x2 minus x1. Now once we've got that, we can say that MR is going to be y2 is, so I'm going to call x2 minus 3, y2 6, x1 0, y1 0. So we get 6 minus 0 over minus 3 minus 0. And that will give me 6 divided by minus 3, which is minus 2. Now this is the gradient of the radius. We want the gradient of the tangent line. Now the tangent line is perpendicular to the radius. We know from circle theorems that the angle between the radius and the tangent is 90, so that must be 90 degrees. So from the equation of perpendicular lines, you would know that the gradient of a perpendicular line is always minus 1 over the original gradient. So in my case, it's minus 1 divided by minus 2, so that will simply give me a half. So the gradient of the tangent now is a half. So what we're going to do, we can then say, right, let's use y equals mx plus c. So y equals to mx plus c is the equation of a straight line. Now, we know that the tangent line passes through minus 3 and 6. So we can say that y is 6. M we've worked out is a half times the value of x, which is minus 3 plus c. In these problems, we always want to work out c. So it's going to be 6 equals to minus 3 over 2 plus c. Now bringing minus 3 over 2 on the other side, that gives me 6 plus 3 over 2. So we need to make sure we know our fractions here. This is over 1, so we need to make the denominators the same. So we times by 2, times that one by 2, and then we can simplify what c is. So that will give me that c is 12 over 2 plus 3 over 2, and that will give me 15 over 2. So I could say that the equation of the tangent is a half x plus 15 over 2. Now, if the question stated just work out the equation of the tangent, that's it, I'll be done. But notice this question says to work out the coordinates of P where line L crosses the x-axis at that point. So if we look at the green line, which is line L, it crosses the x-axis at this particular point. Now this point we call point P. Now whenever a straight line crosses the x-axis, the y-coordinate at that point must always be 0. So what we do, we take our equation, and I'm going to call the origin O. So what we're going to do here is we're going to say that make this equation equal to 0 for y. So we make y equal to 0, and we say a half x plus 15 over 2 equals to 0. So we can solve that, and we can say that a half x, bring in positive 15 over 2 on the other side, we get minus 15 over 2. Now what happens here, this 2 and this 2 will cancel, so I get 1x, or x equals to minus 15. So the coordinates of P would be minus 15 for x and 0 for y. That will be the coordinates of P. But I'm going to extend this question. Now, if you notice on our diagram, we've actually got a triangle, a right-angled triangle here. So we've got that triangle OQP. Now, the base of that triangle is going to be what we just worked out, 15. So we just worked that out here to be, well, it's minus 15. So because that's minus 15, I'm just going to call that a distance of 15. And then we've got the height of that triangle to be, it's the y coordinate. So the y coordinate is 6. So that height of this triangle must be 6. So, and it's a right angle triangle, and we know how to find the area of a triangle. Base times height divided by 2. So we can say that the area of the triangle, so the area of triangle OQP, I believe, yes it is, OQP is base times height divided by 2. So base times the height divided by 2. So in our case, it's going to be 15 times 6 divided by 2. That gives me 90 divided by 2, and that will give me 45. Normally in maths we write units squared when we don't know the area, so we're going to say 45 units squared. And that's it. So I've got another question which you could try. You can pause the video, and when you're done, we'll go through the question. Okay, welcome back. This question says P is the point 1 and 2 that lies on the circle with x squared plus y squared equals 5. Work out the equation of the tangent at P. So now we notice that it has a negative gradient. Why is that? Because it touches the point of P at 1 and 2. So this is the point P, and it has coordinates 1 and 2. This is the origin. Now I'm just going to write O and O just to remind us that's the origin. Just write an O here. So remember that we want to find the gradient of the radius. So you can draw the radius line here. That's the radius. And this is perpendicular to this tangent line. So let's work it out. So we can say MR is y2 minus y1 over x2 minus x1. So MR is going to be 2 minus 0 over 1 minus 0. That's going to be 2 over 1, which is 2. Then the gradient of the tangent, remember, is minus 1 over the radius. That's the gradient of the radius, that is. So it's minus 1 over 2. So we get minus a half. So now we can say, right, if I want to do that, I can now say that we can now, the tangent line passes through P as well. So we can say y equals to mx plus c. So don't forget, x is 1 and y equals 2. We need to always work out the value of c in these problems. So y equals 2. The new gradient now for the tangent line is minus a half. So it's minus a half times the value of x, which is 1, plus c. So again, the examiner is trying to test your knowledge of fractions here. So this will give me 2, and we get minus a half plus c. Taking minus a half on the other side, so we're going to get 2 plus a half. that equals c. This is over 1. And then don't forget, we're going to do times by 2 times by 2. And that's going to give me 4 over 2 plus 1 over 2. And that's going to be equal to c. So we can say c is 5 over 2. Then we can say that the equation of the tangent line is my new gradient now, which is minus a half x plus 5 over 2. Now that makes sense because the gradient is a negative gradient, and we've definitely got a negative gradient, which is minus a half. So let's say we wanted to work out the area of this triangle OP, and let's just call this point A, where it crosses the x-axis. Well, we said that we know that the y-coordinate here is always going to be 0. So let's make this y value 0. So we get 0 is minus a half x plus 5 over 2. And then that's going to give me, we can take minus a half x in the other side. So half x equals to 5 over 2. And like last time, the 2's will cancel out here and there. So I will get that x equals to 5. So this coordinate for A is 5 and 0. So we're interested in the area. So we've said that the base of this triangle is the x distance, which is 5. And the height of that triangle from here down to there is the y coordinate of P, which is 2. So we're now in a position to find the area of the triangle. It's a right angle triangle, so we can say base times height divided by 2. So we can say the area is the base times the height divided by 2. So that's going to be 5 times 2 divided by 2, which is going to be 10 over 2, which is simply going to be 5 units squared.